I am Dr. PALANIAPPAN, Professor of Physics, Department of Physics, ANNAMALAI University, discussing some topics in quantum mechanics. In my previous session also we have seen the relativistic quantum mechanics. This session is also relativistic quantum mechanics, but the difference is now we are moving to the second equation, Klein-Gordon equation or KG equation. There are three different equations in relativistic quantum mechanics. The first one is Schrodinger's relativistic quantum mechanics or Schrodinger's relativistic quantum mechanical equation. Second one is Klein-Gordon quantum mechanical equation. The third one is Dirac's relativistic quantum mechanical equation. All the three equations having a very good continuity means one topic can be understood if we are clear with the previous topic. They are like a chain-like structure. Skipping one loop cannot lead us to the second loop, or if we have a clear understanding of the very first equation, Schrodinger's relativistic quantum mechanical equation, then only we can appreciate the second equation, KG equation. If we understand both of these equations, then only we can go for the third one, Dirac's relativistic quantum mechanical equation. That is, all the three topics are necessary to understand and appreciate. On this basis, though this session is pertaining to Klein-Gordon equation, it is mandatory to have a very brief look of Schrodinger's relativistic quantum mechanical equation. So, as I covered in the previous session, there are two different classifications of mechanics based on size and based on velocity. Combining these two, we have four different mechanics: non-relativistic classical mechanics, non-relativistic quantum mechanics, relativistic classical mechanics, relativistic quantum mechanics. The terms are very essential and should be very familiar to understand. All these four equations, all these four different mechanics are having different equations. The very first one, non-relativistic classical mechanical equation, is E equal to P square by 2m plus V, where E refers to total energy, P square by 2m is kinetic energy, V is potential energy. And the second one, non-relativistic quantum mechanics, is Schrodinger's time dependent equation, IH cross dou psi by dou t equal to minus h cross square by 2m del square psi plus V psi. The third one is relativistic classical mechanics, E square equal to c square p square plus m square c power 4, where E is energy, c is light velocity, p is momentum and m is mass. This equation is available in theories of relativity, Einstein theory of relativity or special theory of relativity, like that. So the fourth one, relativistic quantum mechanical equation, is unknown. It should be determined or it should be predicted from the three existing equations. Schrodinger is the first man to do this equation, and he got one equation, and that equation he derived by two steps. As per Schrodinger, he has two steps. Step 1 is to compare non-relativistic equations. Non-relativistic equations means non-relativistic classical mechanics and non-relativistic quantum mechanics. The purpose is to get classical to quantum parameters. It is the aim of the first step. And in second step, what he did is substitute this classical quantum parameters in relativistic classical mechanical equation. That is, in relativistic classical mechanical equation, E square equal to c square p square plus m square c power 4. E is a classical parameter, P is a classical parameter. Changing these two parameters by this substitution, will make this classical equation as a quantum equation. This is the idea of Schrodinger, and on this basis he first take E equal to plus or minus root of, that is he take a square root c square p square plus m square c power 4, then substitute E and P, and having an equation IH cross dou psi by dou t equal to plus or minus root of minus h cross square c square del square plus m square c power 4 into psi. This is Schrodinger's relativistic quantum mechanical equation. Up to this we have seen the first session, and these steps are essential for the current session, second session. So I am just repeating the main steps. Now we have to go for KG equation, Klein-Gordon equation. Klein-Gordon equation is not a totally new derivation. They just modify this Schrodinger equation, or to be more correct, they just rectify the defects in the equation. This last equation is the Schrodinger's relativistic quantum mechanical equation. The last session itself we have seen that the equation is having two serious difficulties, inadequacies. First thing is the appearance of negative sign. So defects of Schrodinger's relativistic quantum mechanical equation. First thing is negative energy, existence of negative energy, which is not acceptable in quantum mechanics. The second thing is interpretation of del square, square root of del square. Because del square is an operator, mathematical manipulation work. For that we cannot take square root and it cannot be physically interpreted. These are the two defects of Schrodinger's. These two defects are rectified by Klein-Gordon, and the new equation is called as KG equation. And this is the current topic. To proceed with the KG equation, first point, they have accepted Schrodinger's methodology. Accepted Schrodinger's methodology, or step 1 and step 2. Methodology step 1 and step 2. Both steps they have accepted. They told that they declared relativistic equations need not be linear. And the third one, they have taken this notation as gradient function. So with these assumptions, they are able to derive a totally new equation. That is, they just rectify the defects. The first defect is the negative energy existence. Seeing the previous slide, we have seen that a plus or minus sign is appearing in this step. This plus or minus is appearing due to the step taking the square root, e square equal to c square p square plus m square c power 4. Here Schrodinger has taken square root. Taking square root will introduce a negative sign, and this leads to existence of negative energy. This is the reason for the defect. Taking square root is the reason for the first defect. So KG suggested that don't take square root, and as such in this equation we can substitute. The simple idea is also known to Schrodinger, but Schrodinger has purposefully taken square root and proceed with the calculations. But KG suggested that no need to take square root. In the second order equation, e square equal to c square p square plus m square c power 4 is a second order equation. In the second order equation itself, we can do substitution and proceed. That is the idea of KG. Whereas Schrodinger has taken purposefully square root and proceed. Why Schrodinger do this is, any physical equation should be linear. Any physical equation should be linear. Then only it can be interpreted. Say, for example, if I say v equal to 3 meters per second, means velocity of a particle is 3 meters per second. This is a physics equation as well as a mathematical equation. Both are correct. Whereas, if I put v square equal to, that is squaring, v square equal to, if you square this, it will become 9 meter square per second square. Mathematically, this is right. V equal to 3 ms power minus 1, whereas v square equal to 9 m square s power minus 2. Mathematically, these are right. The first equation is a physics equation, whereas the second equation is only a mathematical equation, not a physics equation. Because velocity is a vector quantity. Being a vector quantity, it should have a magnitude. Here magnitude is 3 and it is having a particular direction. On what direction the particle is moving, that can be given by the first equation or a linear equation. Linear means power 1. Here v power 1, so it is a linear equation. This is a valid physics equation. Whereas in the second case, v square equal to 9 meter square per second square, this is not a physics equation because it is a second order equation. In second order equation, we are multiplying a vector with another vector that may leads to a scalar value. So this is only a number is there, the direction is absent in this equation, so interpretation is not possible in second order equation. So the general concept is, any valid physics equation should be linear in nature. A second order or third order equations cannot be a physics equation. That is a general concept existing among the scientists, and because of this fact only, Schrodinger has taken purposefully square root here. E square equal to c square p square plus m square c power 4. He made it as a first order equation by taking square root, and while doing this, he was stuck up with a negative sign and he cannot explain the existence of negative sign, and it is a main defect of his equation. Now, what KG suggested, these are relativistic nature, relativistic equations, means particles are moving with very large velocity, very high velocity, 3 lakhs kilometers per second. With such a huge value, equations need not be linear. That is the assumption made by KG. There is no evidences, no experimental facts, only it is an assumption of KG, and based on this assumption, they are able to take the equation E square equal to c square p square plus m square c power 4. They are not taking square root, they use this equation as such. So the first defect is removed. The existence of negative energy is now removed. How they succeeded with the second defect is that here they are substituting the E value and P value. E value is IH cross dou by dou t and P value is minus IH cross del. On substitution, we have IH cross dou by dou t square equal to c square minus IH cross del square plus m square c power 4, right? Bring the square inside, I square is minus 1 minus h cross square dou square by dou t square equal to minus I square is minus 1 h cross square c square h cross square c square del square plus m square c power 4. Minus square is plus, I square is minus 1, h cross square del square c square, whereas the remaining are the other terms. Now including psi r, you divide each term by h cross square by c square. Divide each term by h cross square c square. You have minus 1 by c square, h cross square will be cancelled, dou square by dou t square equal to, here it is minus del square plus m square c square by h cross square. Bringing this term here, del square, and include psi. include psi. So we have del square psi minus 1 by c square dou square psi by dou t square equal to m square c square by h cross square into psi. Or this entire term is can be taken as a single quantity as dl square. This notation is dl, d D'Alembertian operator. Here the first is del square Laplacian operator. Again 1 by c square dou square psi by dou t square is again a differential operator. All these operators put under dl square psi equal to m square c square by h cross square into psi. But this is not a popular form, and this is the most common term. And this equation is called as Kg equation. Kg equation for a free particle. There is another question, Kg equation for bound particle. So Kg has substituted the E and P value in the relativistic classical mechanical equation. They don't take square root. As such, in the second order equation, they have substituted the E value and the P value. So as per relativistic classical mechanical equation, we have E square equal to C square P square plus M square C power 4, and we have to substitute E equal to IH cross dou by dou t and P equal to minus IH cross del without taking square root, just a substitute. So we have IH cross dou by dou t square equal to C square minus IH cross del square plus M square C power 4. Simplifying this, we have the final equation, that is I square is minus 1 minus H cross square dou square by dou t square equal to minus, squaring minus is plus, I square is minus 1, so there is a minus C square H cross square del square plus M square C power 4. Including the wave function psi, we have minus H cross square dou square psi by dou t square equal to minus C square H cross square del square psi plus M square C power 4 into psi. Divide each term by C square H cross square. We have 1 by C square dou square psi by dou t square equal to minus del square psi plus M square C square by H cross square into psi. Taking del square to the other side, del square minus 1 by C square dou square psi by dou t square into psi. Psi is taken outside equal to M square C square by H cross square into psi. So this is the famous Klein-Gordon equation, Kg equation, but it is only for a free particle. Kg equation, there are two types. One is for a free particle, other is for a bound particle. This is for a free particle. And here we have to list out the merits and demerits. First, merits. It leads to equation of continuity. Equation of continuity is a valid dynamical equation in electromagnetic theory. You know, in electromagnetic theory paper, EMT paper, under Maxwell's equations, there are four Maxwell's equations. Dou B equal to 0, first equation, then del dot S plus dou rho by dou t equal to 0. This equation is called as equation of continuity. In some books it is given del dot J. J or S, it is current density, rho is charge density. So del dot S plus dou rho by dou t equal to 0 is called as equation of continuity. This Kg equation can be transformed into this equation. That is, we can get equation of continuity from Kg equation. Equation of continuity is proved to be a valid equation. Since Kg equation can lead to a valid equation, this equation is also treated as a valid one. So it is the first merit of the Kg equation. Then second thing, Using Kg equation, we can show that integral rho d tau is real. Rho means charge density, integral rho is a total charge, d tau is a volume element. So total charge in a given volume or a space, total charge. Integral rho d tau here refers to total charge in a given volume is real and same. That is, this proves the conservation of charge. Like conservation of energy, we have a charge conservation principle, and the equation of continuity supports the charge conservation principle. These are the merits of the equation. Of course, there are some defects. The defects being, first thing, equation is not linear. Means here it is del square, dou square, that is a second order equation. Any physics equation should be a linear equation, and here it is not a linear equation. It's a first defect. Second thing, this equation is valid only for, is applicable, not a valid, but it can be applicable. It is applicable only for spin 0 particle. Electron is a spin half particle. So for electronic systems, this equation cannot be applied. Or if we apply this equation for electronic systems, for those systems which have an electron, if you apply Kg equation, then the theoretical results largely contradict with the experimental observations, or the theory and the experiment will not match with each other if you apply Kg equation for systems with the electrons. This is another defect. The third defect is, we cannot explain a hydrogen like, are they hyperfine structures? Hyperfine structures cannot be explained even for spin 0 particles. Hyperfine structures cannot be explained using Kg equation. So these are the defects in Kg equation. And so to switch over to another valid equation, we have to go for Dirac equation. But before going to Dirac equation, we have another task to achieve. We have to show that how the equation of continuity can be obtained from Kg equation. That is also a part of the question, and is always, in exam point of view, this is important. So before taking Dirac's equation, we have to see how to get the equation of continuity. How to get equation of continuity. Is the next thing we have to take. This is not a separate question, but it is a part of the Kg equation. Equation of continuity is, as I told, it is del dot S plus dou rho by dou T equal to 0. This is equation of continuity. Here S is the current density, rho is the charge density. They have to be substituted for quantum parameters. How to remember the quantum parameters? No problem, need not be worried, just do the derivations and finally we can check this. So take Kg equation. Taking Kg equation. Kg equation is del square psi del square psi minus 1 by c square dou square psi by dou t square equal to m square c square by h cross square into psi. This is Kg equation. Here psi is wave function in forward direction. It has a complex conjugate psi star. So let it be equation. This is equation 1. This is equation 2. Equation 2 pre-multiplied by. Pre-multiply means you have to multiply at first. Pre-multiply by psi star, the complex conjugate. So it is psi star del square psi minus 1 by c square psi star dou square psi by dou t square equal to m square c square by h cross square psi star psi. This m square c square by h cross square is a constant. Constant can be kept anywhere in the equation. So here psi star is behind the constant. It should be pre-multiplying, means it should be before psi. That we have followed here. Let it be equation 3. Now writing the complex conjugate of equation 2. Complex conjugate. That is, you have to change psi by psi star. complex conjugate of 2 is del square psi star minus 1 by c square dou square psi star by dou t square equal to m square c square by h cross square psi star. It is a complex conjugate. Now let it be equation 4. Equation 4 post multiply. You have to multiply after the terms. Post multiply by psi. You have del square psi star psi minus 1 by c square dou square psi star by dou t square into psi equal to m square c square by h cross square psi star psi. Equation 5. So equation 3 minus 5. Let us find equation 3 minus equation 5. First term, left hand side first term minus first term, left hand side second term minus second term. Similarly, right hand side you have to subtract. So first term minus first term is psi star del square psi minus del square psi star psi. First term minus first term is over. Again the second term. Here second term minus 1 by c square is commonly available. So minus 1 by c square. First term is psi star dou square psi by dou t square minus, here the second term is dou square psi star by dou t square into psi equal to, while subtracting right hand side it will become 0. Both are equal, so it is 0. Again here I am taking on, here first del square, here also del square, I am taking on del outside, so del into psi star del psi minus del psi star psi minus 1 by c square. I am taking on dou by dou t outside, so dou by dou t. So for here psi star dou psi by dou t minus dou by dou t psi star psi equal to 0. Again this term is called as charge density, current density S. So it is del dot S. Here I am taking or interchanging the two terms within the brackets. Here psi star dou psi by dou t is first term minus dou psi by dou psi star by dou t into psi is the second term. I am just shuffling the two terms. Or it can be said this minus is taken inside. Anyway you can treat. If you taken this minus, the second term will become first term and the first term will become second term, so that it is, this negative sign will become positive 1 by c square dou by dou t. Here the second term is to be taken as first term, so dou psi star by dou t into psi minus second term will become first term, psi star dou psi by dou t equal to 0, or dou by dou t is written first, del dot s plus dou by dou t into 1 by c square dou psi star by dou t into psi minus psi star dou psi by dou t equal to 0. Here this is called as charge in 0. So what you have is del dot s plus dou rho by dou t equal to 0. This is equation of continuity. We start with kg equation and we end up with equation of continuity. As this equation can be derived from kg equation, it is evident that kg equation is a valid dynamical equation. So with this kg equation for a free particle is over. Kg equation is of two types. One is for a free particle, other is for a bound particle. Bound particle is otherwise asked as for hydrogen atom. Kg equation for hydrogen atom is same as kg equation for a bound particle. Now we have completed kg equation for a free particle. So we may see the kg equation for a bound particle in another session and the Dirac relativistic equation in one more session. Thank you.